Hello everyone, myself Gauri Sonone. My subject is analytical chemistry. In first chapter is volumetric analysis. The volumetric analysis there are seven. It's the end of the unit in the student expected to below the seven question. The first upon the answer and questions such as firstly. First is the what is volumetric analysis, titration, equivalent point, end point, primary standard, titron and what is standardization. Second is calculate the volume of titron at the equivalent point. Third question is understand the method that are used for the detection of the equivalent point. Now the requirements for for a reaction to be applied in a volumetric analysis. Answer the question what is titration curve, what is its important, how it can be derived. And sixth question is calculate the concentration of all species participating in titration reaction at any point during titration. And seventh is the do all sort of volumetric calculation. There is the seven question in volumetric analysis are most important topic for the chapter. Firstly, the first question is what is volumetric analysis, titration and equivalent point. First, the answer of this uh, question. For in volumetric analysis, a chemical called a titron is added to a solution of known concentration called analyte, that is the titron, together with an indicator that will mark the time at which all the analyte has been reacted. At this point, the analyst can determine how much analyte is originally present from the amount of titron added. It is sometimes called volumetric analysis because all experiments under this type of analysis are completed by titration reaction. It is highly precise, easy process, fast result and only simple apparatus is required. Volumetric analysis takes place in a wide variety of situations such as industrial laboratories, hospital laboratories, forensic science laboratories. Titration is important in environmental chemistry, food, beverage, and pharmaceutical industry are useful in volumetric analysis. Next is the volumetric analysis. Volumetrically measure the amount of reagent, that is the titron, required to complete a chemical reaction with the analyte. A general chemical reaction for volumetric analysis is in general reaction small a capital A plus small t capital T to give product, where small a is the moles of analyte and capital A is contained in a sample, react with small t moles of the titron, capital T in the titron solution. Next is the reaction is generally carried out in a conical flask containing the liquid or dissolved sample. Titrant solution is volumetrically delivered slowly with shaking to a reaction flask using a burette. Delivery of the titrant is called as titration. Okay. And the next definition is titration. First is analyte, second is titrant, next is the titration. The titration is a complete when equivalent titron has been added to react with all analyte according to the balanced titration reaction equation is called as equivalence point. Next is the an indicator often added to the reaction flask to a single when all the analyte has reacted. The titron volume where the single is generated is called the end point of the volume. This is the end point definition of volumes or titer. The equivalence and end points are rarely the same, that is the titration error. Volumetric method have the potential for a precision of up to positive or negative 0.1%. or less. In diagrammatically, the burette or standard of titration solution, tap, conical flask, analyte solution, and titration term. This is the diagrammatically in titration process. Firstly, the burette and conical flask and titration process. Next is the calculating the volume of titrant at equivalent point. If the number of moles or millimoles of the analyte in the conical flask is known as in the case of the correcting for endpoint errors as we will, then we can calculate V equivalent point as shown in following example. Firstly, for example of in case of titrating in 10 ml solution of 0.1 molar chlorine or Cl minus in the conical flask by 0.2 molar solution of Ag plus, that is silver, in the burette, calculating the volumetric equivalent point of Ag plus solution. Therefore, the solution of this problem in reaction Ag plus plus Cl minus to give the product AgCl, millimoles of Cl minus is equal to millimoles of Ag plus in x mole is the 1 upon 1, that is the value 0.1 moles in chlorine into volume is the 10 is equal to 0.2 millimoles into V equivalent per mole. मग V व्हॉल्यूम काढायचं असल्या कॅल्क्युलेट द V इक्विव्हॅलंट किंवा व्हॉल्यूम्स इन इक्विव्हॅलंट प्रोडक्ट V इज इक्वल टू 5 ml of Ag plus solution, that is the silver solution. This is the problem. Next is the example number second. In case of titrating, second example is the same as first example. In case of 10 ml of 0.1 molar of H2SO4 solution by 0.2 molars of NaOH solution, calculate the volume of the equivalent per product of NaOH solution. The solution of this problem is firstly the general reaction of 2 moles of NaOH plus H2SO4 to give Na2SO4 plus twice H2O. The millimoles of H2SO4 is equal to millimoles of NaOH into 1 by 2. Why 1 by 2? That is the 2 moles of NaOH. The 10 into 0.1 molar solution is equal to 0.2 into volume ml into 1 by 2. Now V is equal to 10 ml of NaOH solution. Next is the equivalent point can be detected by observing or measuring a sudden and sharp change in one of the physical properties of the resulting conical flask solution due to sudden and sharp change of the concentration of one of the reactant or product of the titration reaction. There are different methods to detect the equivalent point include firstly color change that can be detected by naked eye. In some reaction the solution changes color without any added indicator. This is often seen in redox titration, for instance, when the different oxidation state of the product and reactant produces different color, as we will see paramagnet MnO4. This sometimes called autodetection, that is the reaction MnO4 is the violet color plus 5Fe2 plus 8H plus to give Mn2 plus 5Fe3 plus. This is the colorless plus 4H2O. Second question is, this method is a limited and less sensitive, so it cannot be used for dilute solution. First one is the specific indicator and third is the equilibrium indicator. First is the specific indicator. Each one of these indicator produces a colored product with only one substance, example starch from the blue complex with iodine, and thiocyanate is the SCN minus from red complex with iron. Third, as we will see later, these indicators are limited, so you may say that this is the only well known specific indicator. And third is the equilibrium indicator. These indicators are found in two forms, that is, these indicators are found in two forms of different colors of depends only on the change in the physical property of the titration solution, that is the conical flask solution, such as pH acid base titration, that is the first is the H in to give H plus ion minus color A and color B. This is the potential of the redox reaction. Redox reaction is the gain of electron, ion oxidation plus Ne electrons to give ion reduction, the color A and color B. Next is the regardless and nature of titration of the reactant or product. This type of indicator will be discussed in the latter lecture. First one, measured properties. This method depends on the measurement by the instrument of physical property noticed by the naked eyes of the titration solution during titration, such as electrical conductivity of the solution or its voltage, or in intensity of the electric current passing through solution, or absorbance of electromagnetic radiation by the titration solution, etc. This method is outside the scope of course, will be discussed in details in subsequent course. Next one is the primary standard. It is a substance that is 100% pure or its purity is well known. For example, if the weight required for the preparation of substance solution is 9.5 gram of the substance and power is 100% pure, and pure we get 9.5 gram and dissolve in it a desired volume to get a standard solution. But if it is, let us say, 95% pure, in this case to get 9.5 gram of substance we have to wait 10 gram of the substance power. But if it is pure and purity is accurately known, this case we wait 9.5 gram and dissolve in the desired volume, and then standardize this solution with another standard reagent solution, final its real concentration. This is what is called as standardization. Note that the substance pure and its purity is the well known. There will be no need for standardization. Next is it is solution should be preferably be constant, that is not affected by the components of air or heat, so you do not need to standardize it or prepare it daily. Third is it should be available at a reasonable price and its solution is easy to prepare. The primary standard is the fourth point is it should meet the titration reaction requirement which we will discuss later. And last point is it is molecular weight preferably be highly in order to reduce the weighting error. For example, to prepare